Okay, so lesson 2.7. We're going to be, again, solving proportions. But in this particular lesson, we're going to be solving proportions after we set one up from a word problem. We have a introductory paragraph of notes that I want to read through. It says a ratio compares two numbers by division. The ratio of two numbers a and b can be written in three ways. Okay, so we can write a ratio in three ways: a over b, a colon b, and also a to b. And for every a units of one quantity, you have b units of another quantity. A ratio that compares quantity measured in different units is called a rate. A rate with a denominator of 1 is a unit rate. So the first problem for your homework is yes or no, did you read the I can statement and introductory paragraph? So please be careful and bubble in your correct answer. Okay, in problem number 2, we're comparing unit rates, and it says you are shopping for t-shirts. Which store offers the best deal? Is it store A that offers 2 shirts for $25? Is it store B that offers 4 shirts for $45? Or store C that offers 3 shirts for $30? Okay, so we want to get we want to set this up and get the proper rate here. So for store A, I'm going to write this up top here. So in store A, it's $25 for 2 shirts. So if we do 25 divided by 2, that's going to be 12.5, or $12.50 per shirt. Okay. If we look at store B, it's $45 for 4 shirts. If we do 45 divided by 4, we're going to get $11.25 per shirt. Okay, so these are the unit rates here. So $12.50 per 1 shirt, $11.25 per 1 shirt. Okay, and then finally, store C, we have $30 for 3 shirts. Okay, so notice we set up all 3 of these as ratios. And 30 divided by 3 is going to give us $10 per shirt, or $10 per one, or for 1 shirt. So what is the best deal? So the best deal is going to be store C, because the unit rate is $10 for 1 shirt. That's the cheapest out of all 3. Okay, we're going to look at number 3 now. So now we're going to use proportions to solve the word problem. An MP3 player has 2 gigabytes of storage and can hold about 500 songs. A similar but larger MP3 player has 80 gigabytes of storage. How many songs can the larger MP3 player hold? Alright, so let's set up a proportion. So the first MP3 player has 2 gigabytes and can hold 500 songs. So we're going to write 200, we're going to write 2 over 500. That's going to equal the larger MP3 player. It has 80 gigabytes of storage. But we don't know how many songs it can hold, so we're going to replace it with X. Alright, so you're making sure that if you started with gigabytes up top, over here you had gigabytes up top as well. Right, so and then songs were both on the bottom there. Alright, so you want to make sure that those are matched up, and now you can cross multiply. So 2 times x is going to give us 2x, and that equals 500 times 80, so cross multiply here. So 500 times 80 that's going to be 40,000. Solve for x, so we're going to divide by 2. So x equals 20,000. So how many songs can the larger MP3 player hold? D, 20,000. Okay. All right, let's look at number 4. An 8-ounce can of orange juice contains 97 milligrams of vitamin C. How many milligrams of vitamin C are in a 12-ounce can of orange juice? Alright, let's set up a proportion. So 8 ounces, you got an 8-ounce can of orange juice, and it contains 97 milligrams of vitamin C. So I write that ratio. I'm going to set it equal to another ratio, and I'm going to make sure ounces is up top and milligrams is on the bottom. Alright, you got to keep it consistent. So about how many milligrams of vitamin C are in a 12-ounce can of orange juice? So we know we're gonna fill in 12 for the ounces, and we want to know how many milligrams is in 12 ounces. So we're gonna replace. We're gonna put X there. Now we're gonna cross multiply. So 8x, 8 times x is 8x, is going to equal 97 times 12. That's going to give us 1,164. We're then going to divide by 8 both sides. So we have x equaling 145.5. So how many milligrams of vitamin C are in a 12-ounce can of orange juice? E, 145.5. Alright, so with these word problems, they're not overly difficult. The one area where you just have to be careful is when you write your ratio, or when you set up your proportion, make sure that the units that you're using match up. So if you had ounces up top in one ratio, your other ratio, the ounces, have to be up top as well. You don't want to go switching them up. And then you shouldn't have any issues with this. So, short video. Go ahead and finish the rest of this worksheet. Okay, there's a couple more word problems, and then there's a review on just solving the basic proportions and problems that we've done previously throughout the year. So, good luck, and I will answer any questions when I'm back in school.